Hey team, welcome to this tutorial on addition polymerization. So what is the meaning of this? Well, let's start off with polymerization. This portion of the word, poly, means many. And in this case, when we're talking about polymerization, we're talking about many monomers. Monomers, what does that mean? Monomers basically means single units of the same type of atom. It's kind of like when you're making a necklace and you're following this pattern of a red bead, a grey bead, and maybe a green bead. And you repeat that pattern again and again and again. Okay? And so the single repeating unit is known as a monomer. Many of these monomers makes a polymer. And when we're referring to addition polymerization, this is when we have to break open double bonds to add other groups of atoms, or in this case, more monomers. This is why you cannot get a polymer from an alkane because it only has single bonds. You need a double bond for an addition reaction to be able to happen. Okay? Below, what I have here are some examples of how we can turn a monomer structure into a polymer structure. How can we take a monomer, copy and paste it, repeat it until we get a long-chained polymer? Well, here are my steps to do that. First of all, what I like to do is I like to acknowledge that there's a double bond here. This double bond needs to open so that we can allow for an addition reaction to occur. So this double bond is going to open out, okay, onto either side of the carbons that are involved in the double bond. So they'll open up, but for that to happen, there needs to be free space in this area, okay? And so what we need to do in that case is we'll probably need to move these hydrogens just so that they are out of the way and can allow the double bonds to open up like this. I'm going to draw the monomer that is allowing to be turned into a polymer in this box over here. So we've got the double bond over here that has been opened up. Remember in the previous tutorial that I've given, we know that whenever a double bond opens up, we have to replace it with a single bond, okay? That's just because carbon can bond to a total of 4 things, and so when we take away that double bond, we replace it with a single bond so that each carbon is still bonded to 4 things, okay? Feel free to visit that old tutorial if you need a recap on that. But this is what we have so far. We've moved those hydrogens so that they're out of the way and have made room for those previous double bonds to open up over here, okay? And so in this example, or these examples, we're drawing 3 repeating units of the monomer. So right now, I have 1 repeating unit. I have to have 3. And so all I have to do is basically know that if this is 1 repeating unit over here, I need to be able to draw 3 of them. So I'm going to go ahead and do that. We've got this carbon-carbon bonded to the hydrogens, another 2 carbons bonded to hydrogens. And so let me make that very clear that this is the first monomer, this is the second monomer with 2 carbons and 4 hydrogens, this is the third monomer. What we like to do is to show that this is just a segment of a long polymer chain. We extend that last bond out this way, and we can put that in a bracket usually and show that there's a number of repeating units that are beyond just this 3 repeating units that we've drawn here. Okay. All right, next example. Let's go ahead and look at this molecule propene over here. So we see that we have a double bond. Let me highlight it again. And it has to open up on either side of each carbon. But there's an issue. This double bond can actually, let me get a pen. This double bond can open out here. There's no issues there once we move the hydrogens slightly this way. But this double bond cannot actually open up over here because there is this whole group that is existing on this side of this orange carbon over here. There is no room for this double bond to open up to. So what am I going to have to do? I'm going to have to make space. So I'm going to take this whole chunk, this methyl group, and I'm going to swivel it. I'm going to swivel it out of the way. I'm going to move it down here. That's going to allow room for this double bond to open this way. I'm going to show you exactly what that's going to look like. Take time to do it yourself if you feel like you can do it, and then play the video to check the answer. So here we have it. I've got this carbon situation, and its double bond has opened up. Okay, hang on a second. Let me just draw that double bond to begin with. So we've got this methyl group over here. Okay, we've got that methyl group over here. And remember how I said I'm turning it, I'm twisting and swiveling it down here. Okay, so let me go ahead and do that so that you can clearly see how that looks like. So I'm drawing this methyl group down here. Then this has got the hydrogen over there. I've done that one. Now I'm going to draw this hydrogen swiveled more over this way, and then moving this hydrogen this way. So now you can see that this double bond can actually open up on either side of the carbon because there is space. So let's go ahead, let's go ahead and do that. I will open up, break the double bond, open it up, replace that double bond with a single bond. And boom, I have the chance to now repeat this monomer again and again and again to get a polymer. So let me highlight that. This is what we can extend into a nice necklace in a way. It's my little analogy. We can extend it further. And so I'm going to draw this out. So there we have it. I have 3 repeating units of the monomer that we just drew. And so now let's move on to the next example. Again, let's acknowledge where that double bond is, okay? And we have to open up that double bond and make sure that there's room beside each of the carbons in the double bond. As you can see here, we have some obstruction going on. There's this group, and then there's this group that we need to clear. Okay, we want the space beside each carbon over here to be clear. So I might swivel this. There's space to move them and swivel them around. So this group will move here in this plane, and then this whole group can move down here. Okay, the hydrogens are in a good space. They're already out of the way. Let's focus on moving those blue methyl groups. So starting off with that double carbon bond. Okay, we've got those hydrogens which are nice and out of the way. This blue group over here, I'm going to move it so it's over here. Okay, and then again I'm going to move this blue group down here. Cool. Now you can see that there's space. There's all this space beside each of these carbons. So that's where I'm going to open up those double bonds. Cool. And so that is our single repeating unit. Cool, we've got 2 more examples to go. Hopefully you've got the gist of it by now, but if you haven't, stay with me, I got you. We've got this double bond here, and then we've got these carbons on either side of that double bond. And so we see that the space is not clear beside each of these double bonds. So we're going to move whatever's on either side of the carbons aside. Okay, so these are the groups. I'm going to move this over here and this over here. So let's draw that out. We've got the double bond, double carbon bond. I'm going to move that big group, and just to write it in short form, I'm going to write CH2 to represent this over here. It's got a C and two H's, so that's CH2. And then that's joined on to a CH3. So I'm going to write that here, CH3. And then I have that hydrogen down here. I've also got that hydrogen that was there. And then I'm going to focus on this group now. It's a CH3 group. So I'm going to write CH3 down here. So now the spaces between those two carbons are indeed free for that double bond to open up. So let me go ahead and open up that double bond. Let's get that carbon back. There it is. There we go. Easy peasy. Now we just have to draw 3 repeating units of it. So let me go and do that. There we go. That's our polymer. Okay, last one to go. Again, let's identify that double bond. Let's identify the carbons involved in the double bond. Let's look at the groups that are obstructing our double bond from opening. Those groups are this methyl group over here. And then we've got this group over here, which we need to move out of the way. I will move this group over here in this space, and then I will move this group over here in this space. So what should this look like? So far, we have this going on, and an H down here. Let's move those groups now. So what I have is a CH3 group, which is this one, and then I have another CH3 group over here. Okay, so there we go. We've got our little unit. Let me open up those double bonds now. Cool, and then get 3 repeating units of that. Nice. Okay, final thing, brackets. Easy peasy, and this is how we do it. This is how we roll. Okay, now this is the skill that we've just learnt. We've learnt how to make a monomer, which is a single repeating unit, into a polymer, which is multiple single repeating units joined together. What we're going to focus on next is going from a polymer chain to a monomer, okay? And so the polymer chain looks something like this. And so we're going backwards. We're going from longer chains to the single monomer structure, okay? And so here we have it. The first step in this case is to identify the single repeating units, and then we are going to reform the double bonds which were broken open to form this thing. So if we look here, let's see if we can find the pattern. Okay, so we've got one carbon bonded to a hydrogen and a C2H5 group. Then we've got a carbon bonded to 2 hydrogens, okay? Then we have a carbon bonded to a hydrogen and a C2H5 group, which is very similar to this one. In fact, it's identical. So this seems like it's the start of a new pattern. So in one monomer, this is what we have, okay? Because then it starts all over again from here, okay? So we can identify that this is a single repeating unit that is occurring. All right, now that we've identified what a what a monomer could look like. Let's go ahead and redraw that over here. Nice. Okay, so we've got this. But remember, a monomer structure has the double bonds, okay? The monomer structure needs to show that it had the double bonds to begin with, and then it opened up. So let's go ahead. All we need to do to form the double bonds is basically close them in, okay? So if we do that, what that will look like is we'll take away these guys and basically draw a double bond here. And so that's what the monomer structure looks like. And that kind of looks similar to some of these ones here that we started off with. Okay, monomers have to have that double bond present. That's how the polymer came to be. Okay, so as we can see here, we've got this structure. And what we can do is we can identify how many carbons are within this structure, okay? We can identify how many carbons are in this structure, and we can see that there's there's 1, 2, 3, 4. So this name will have the prefix bute. We'll have bute 1-ene because it's an alkene, and we put a 1 over here because we know that that double bond is between the first, second carbon. Okay, so that's how we go. If you wish to draw this another way, you can also draw this as a straight chain, similar to the ones that we have here. And so instead of drawing this group down there, we can actually draw it so that it's over here. C2H5. That's another way of drawing it. So the next thing that we want to do is look at this one over here. Let's identify the repeating unit. See if you can do it. Otherwise, continue watching the video to find out what to do. This is one repeating unit, and we know that this is a repeating unit because it restarts as the same pattern over here and here. Okay, let's go ahead and draw one of these repeating units, and then we can find out what our monomer structure will look like. So let's start off with what we have drawn literally over here, CH3, and then we've got an H over here. There's bonds over there, there's an H over here, and then there's a C3H7. Okay, the first thing to do is we need to fold in these double bonds, okay? So let's go ahead and do that. Let's fold in those double bonds. Let's get rid of them. Cool. Now that we've folded in the double bonds, we can sort of make this a linear structure. We can swivel this whole C3H7 group around here and draw it kind of like this. Got 3 carbons, as we can see here, according to the structure. And then we've got 7 H's, hydrogens. Cool, and that represents our monomer structure. Okay, and if we're to name it, let's just count the carbons. We've got 1, 2, 3, 4, 5. 6 carbons, actually. And so we can write this as hex to represent the 6 carbons. We can write 1 to show, we can write actually, we can write 2 to show that this double bond is in between the second and third carbon over here. If we need to make sure that that double bond's on the lowest labeled carbons, remember, in our naming rules. So if this is the first, this is the second, this is the third, fourth, fifth, sixth. So our double bond is between the second and the third. So we say hex 2, and to end it, we write ene to show that this is an alkene. Okay, so there we go. That's how it is done. Let me just leave those numbers there for reference. Okay, cool. So that's a hex 2-ene monomer which forms this polymer. Let's try this example here. What we have is, let's see if we can find a repeating unit. We've got one here, and honestly it's going to be different. Sometimes in some examples you'll have 3 carbons which makes up a monomer, or 4 or 5. Who knows? So you just need to make sure that you understand how to identify the monomer provided, because it will be different for your exams. You'll come across different contexts. Okay, and so here we are, we've got this polymer. Let's redraw that single monomer. We've got 2 carbons. We've got a C2H5 group, we've got a hydrogen, we've got another C2H5 group, and then we've got a hydrogen. And so what we need to do, I've jumped ahead a little bit, we've got these bonds here that we need to close in to form the double bond. So let's go ahead and do that. Cool. Now what we can do is we can linearize this chain a little bit. Okay, so I can move this group over here, and then I can move this group over here. Okay, so I'm going to go ahead and do that. So I've got C2H5, so I'm going to draw 2 carbons, C2H5. Cool. And then I'm going to move this C2H5 over here. C2H5. Boom. And what is the name of this monomer structure? Well, let's count the carbons. We have 1, 2, 3, 4, 5, 6 carbons. So let's write the suffix for that, sorry, the prefix for that is hex. Hex. And where is that double bond? It's, I think it doesn't matter which way we number the carbons because it's right in the middle. So if this is 1, this is 2, this is 3, 4, 5, 6, okay, that means that double bond is between the 3rd and 4th carbon. So we take that lowest number and write 3 and ene to show that this is an alkene. Hex 3-ene is the monomer name. Okie dokie, we've got our last one. I reckon you got this in the bag, but I'm still going to do this anyway, just in case there are some of you who are still a little bit unsure. In this case, again, our monomer consists of 2 carbons and these 4 groups in total. Got this monomer and this monomer. Cool. Let's redraw that monomer. Sometimes it helps to draw it on a scrap bit of paper first, and then in your exam booklet you draw the real deal out. Okay, got that CH3, we've got an H, we've got a CH3 over here, we've got an H, and then we've got those bonds which are extending. We want to fold those bonds in to form a double bond anyway, so let's do that here. Now we can sort of straighten out this alkene a little bit so we can get a chain within the structure, a straighter chain. And so I'm going to move this CH3 group over here. And then we can also move this CH3 group over here, just so that we can easily count the longest chain when we have to go to name it. And so as you can see here, we've got 1, 2, 3, 4 carbons. So what prefix will this give us? That's right, it gives us bute. The double bond is in between the second and the third carbon. Doesn't matter which way you count it because it's bang smack in the middle. So it's going to be bute 3ene. Wonderful. So that's basically your notes, okay? This is how you kind of describe addition polymerization, understand that it only occurs with alkenes, not alkanes, because of that double bond to allow a addition reaction. This is how you go from monomers to polymers, and this is how you go from polymers to monomers, okay? And so stay tuned, because maybe I'll post up some past exam questions, and we'll go from there. But that's all for this tutorial. Hope it makes sense, and I'll see you in the exam tutorials.